All right, welcome back, geometry crew. All right, so we've covered all the sections in chapter 10, which is our circles chapter. Remember, we were just planning to have a test just on 10.6 and 10.7, which is all about the segments and writing equations in a circle. So we're going to review any types of questions that might be on the test for these two sections. So I've got 13 problems outlined here. In day one, I figured, let's do a lot of questions today, and then tomorrow we can do a little bit less, maybe skip some here and there. All right, so let's get started. We'll go through this rather quickly, and if you have questions, you can email me. All right, so we've got these two chords inside the circle. So the product of the parts of the chords. One second, got some headset issues, so let me stop really quickly. And we should be good. The product of the parts of chord 1 should equal the product of the parts of chord 2. So that would be 20 times 27. Okay, now from there, we have 18x equals 540. Divide by 18, and we get x equals 30. Now you'll see a common theme in these questions. You'll see that the first one's rather simple. The second one, okay, maybe we have to factor or something like that. So increasing in difficulty like every 2 problems for the first couple sets of problems. So if we take a look at this next one, all right, once again, it's the same deal. The product of the parts of one chord equals the product of the parts of the other chord. All right, and then from there, we distribute. We get x squared plus 8x equals 180. Subtract 180. All right, we've got to notice that this is quadratic. We can't just solve this simply because we have this positive 8x as well. So we've got to get everything over to one side and then try to solve by factoring. If factoring doesn't work, then we'll go to a different resort like quadratic formula. All right, so we're looking for 2 numbers that multiply to be negative 180 and add up to be positive 8. That one's pretty simple there. We have 10. Wait a minute. No, not 10. All right, sorry, not 10, negative 10. And then positive 18. All right, so set each one of these equal to 0 and solve, and we would get x equals 10, x equals negative 18. And just a really quick check, if we take a look right there, negative 18 wouldn't work. So we just get x equals 10. All right, if we take a look at the next, we have a secant-secant relationship. So in this case, external times whole, which is x plus 5, equals external times whole, which is 10. All right, we distribute, multiply, put our variables on one side, all right, constants on the other, so that means subtract 25, divide by 5, and we get x equals 7. Again, that one's pretty easy. Next one, a little bit more difficult. So if we take a look at the bottom secant segment, we have external part times the whole thing, which would be 2x minus 8. And that would equal the external part of the other secant segment times the whole thing, which is 14. Now we've got to multiply and distribute. All right, so if we distribute here and combine like terms, we get 2x squared minus 14x plus 24. 6 times 14 is 84. Now let's get everything over to one side. So we get 2x squared with minus 14x minus 60 equals 0. And now we factor. All right, so the first two terms right here is going to give us 2x squared. We got 2x times x. Now on the last part right here, all right, those two have to multiply to be negative 60, and then we got to keep in mind that the outer and inner parts of FOIL have to add up to be negative 14x. So we got to do some guess and checking, manipulate a little bit, and then try it until we get it. All right, so positive 6 and negative 10 would be that combo that works, because then we would have negative 20x for the outer parts of FOIL, and then for the inner parts of FOIL, 6x, and that adds up to be that negative 14x. Okay, so that's the one that works. We set each equal to 0 and we solve. All right, if we set 2x plus 6 equal to 0 and solve, we get negative 3. A quick look at the problem will tell us that won't work. And then if we set x minus 10 equal to 0, we get positive 10. That's the one. All right, let's try out 5 and 6 now. Increasing in difficulty here. Remember this, in this case, we have a tangent and a secant. So tangent squared equals exterior times whole. So the whole thing there would be x plus 16. All right, now let's distribute and multiply. So we got 400 equals 16x plus 256. Get our constants on one side, so subtract 256. And we get 144. Divide by 16. And that gives us x equals 9. All right, this one doesn't really increase in difficulty much, but it is a quadratic. Okay, so it's just testing our knowledge of solving quadratics here. All right, so the tangent is x. So tangent squared equals exterior times the whole thing. That's 18, remember. We add them up. Okay, and then from there, multiply. We've done this before. We've gotten 144. Take the square root. We get x equals positive and negative 12. Double check the problem. Oh, negative doesn't work. Just the positive. We can't have that negative distance. All right, now we're transitioning to section 10.7. We went over a lot of different scenarios last time on 10.7. So we got a decent amount to cover, but we'll go through it rather quickly. So identify the center and radius of each. All right, remember it should read, if I just rewrite standard form of a circle, standard equation of a circle, it should read x minus h squared plus the quantity y minus k squared equals r squared. All right, so right here, the center is h comma k. All right, and that would be 1 and then negative 5. All right, notice we don't see that negative here, so that means that what we're subtracting is actually negative 5. Okay, r squared equals 16, so that means r equals 4. So we have a center of positive 1, negative 5, and then a radius of 4. All right, so we can just identify it from the equation. All right, in this case, we got to identify the center and radius from the equation, but then after that, we got to sketch the graph as well. So the center in this case is 1, negative 1. The radius is 4. So the first thing that I'm going to do is I'm going to plot that center point. So 1, negative 1 is right there. And then from there, okay, we're going to use the radius to get multiple points that are on our graph. So I'm going to go 4 units right, 4 units left, 4 units up, 4 units down. Okay, I got 4 points on my graph. Now I'm just going to draw the circle. Like I said before, okay, right here at these points, it's just going to seem like it doesn't change as much. All right, once again, I am not a good artist. I will repeat and repeat and repeat that, but I try to be. I try my best and fail many times. That's okay. All right, and then once we've got this kind of outlined, we can just fill in the rest of the part of the circle, and we get something that's not too bad. Oh, that was a little, but there we go. It's reasonable. I'll take it. All right. And 9, now we need to get the equation. So that this is a little bit more mathy here. Okay, we got to go a little bit more mathy for these last examples. Okay, so our center is that point h comma k, and remember the standard equation of a circle is as such. So now we just got to plug in what we know. Instead of writing minus and negative, just going to write a plus. So x plus 12, that quantity squared, plus the quantity y plus 7 squared equals 5 squared. All right, you don't have to rewrite the whole thing. You know, you could just do 5 squared and get that equation. I'm just showing you how we get everything. So that's how we get our final equation, which equals 25. All right, and kind of like before, this next one ramps up in difficulty a little bit. Notice the radius is 4 root 2. Okay, so we're just going to go, basically, we're just going to go over how do we square that value. All right, so we have the quantity x minus 3 squared plus y minus 7 squared from the previous example with our center point, h comma k. We're plugging that into the standard equation for a circle. All right, and then right here should go r squared. Okay, well, r squared is going to be 4 root 2 squared. One thing that we got to make sure to do is we want to square that whole value. Remember, when I say that whole thing, I mean put it in parentheses. Okay, so if we square that whole thing, that means we got to square 4, and we got to square root 2. All right, if we square root 2, the square root of 2, we just get 2. 16 times 2 is 32. So this thing equals 32. All right, couple left. All right, if we're given a graph, we've got to identify the center. Okay, here's our center point. That's -2, 1. All right, and then we have to figure out the radius. Okay, so this changes 3 units. So that means the radius is 3. All right, so if the radius is 3, that means r squared, which is what we're going to use in the equation, is 9. So now let's plug all this in, okay, to the standard equation for a circle. We got x minus the x value, which would be x plus 2, that quantity squared, plus y minus the y value, that quantity squared, equals r squared. All right, for the last two, we just have the center and a point on the circle. So we got to find the radius. Remember, the radius is just using Pythagorean theorem. And more specifically, we don't even need to find the radius. What we need to find is r squared. Okay, and finding r squared is much, much simpler. Okay, r squared is just going to be the difference between the x values squared plus the difference between the y values squared. That's how I like to put it. To make it simpler, we don't have to do, copy down all of these numbers and do all that math. All we got to do is find the difference between the x values. Okay, the difference between the x values here is 5. The difference between the y values here is 1. So that's 5 squared plus 1 squared. And we're talking about distance. Okay, radius is all about the distance. We don't care which direction we're going. We just want to know the distance. All right, so if we do 5 squared plus 1 squared, we get 26. Now, since we have the center point, and then we got the radius squared, we can write the equation. So we have x minus 11, that quantity squared, plus the quantity y plus 4 squared equals 26. All right, lastly, if we take a look at 13, we're finding the radius again. In this case, all right, one thing that you could recognize is that the y value doesn't change. So what we're talking about here, okay, if we're talking about a center and the point on the circle, that y coordinate's not changing. If you notice, you'll just see the x coordinate changing. Okay, the center point's here. All right, that point on the circle is right there. So really, we could count if we knew that graphically. All right, otherwise, we could do this algebraically, and once again, we're doing r squared equals the difference between the x values squared, which is 3, so 3 squared, and then the difference between the y values, like we said, is 0. All right, so if we plug this in, well, 3 squared plus 0 squared is 9. Now we have the radius squared. All we need is the center, which we've got. So we have the quantity x plus 16 squared plus the quantity y minus 16 squared equals 9. All right, folks, that was the last one. Once again, if you have any questions, please let me know. Email me. And tomorrow we'll go over, similar types of problems. Maybe I won't go over the same amount, but just getting us ready for that 10.6 to 10.7 test. All right, folks, have a great day.